Hello, guys. Good morning. Thank you for the opportunity for us to join you guys here and share a little bit of what we are doing at PicPay about spatial data. So today, our case will focus on a specific problem we have about how to focus and devise our sales force across Brazil. But before, I'll explain to you guys a little bit about PicPay and so you can better understand the problem. So PicPay is a wallet and it's an app that people can use to make payments, and its mission is to simplify the way people treat and how they use money. So our goal is for everybody to use daily PicPay to pay accounts, to transfer money to other people, and we have a lot of stakeholders. We have our clients that are people that want to use our platform to do these things are I just shared, and we also have business that receive payments from these people. So our platform, um, Fernando, you can.
Right. Yeah.
So we focus on four core business units, the payments business units, and we have QR code paying methods. We have transfer money 24 hours a day, and we also have investments that here people can they leave the money at their wallet, and it yields some investments. We have a store where people can buy other services from partners. Example, Uber, PlayStation. They can buy credits and use these credits in these other platforms. And we also have our credit card that people can use to buy and use the credit card to use it in physical establishments or even online when they are not using the app. So, what is our problem and what is our challenges when we talk about this problem? Brazil is a large country, and we don't have the possibility to have executives and people on the streets around all Brazil because it's a very big place. So we have to optimize and choose where do we want to focus our sales force? Where do we want to send our executives to talk to business on the street and so they can join PicPay and people can use the app to pay in these commercial establishments. So in order to do this, we have to divide Brazil and use a method so we can send these people to the best places that we would have the best results. And in order to know if we're having the best results, we need to monitor these results in homogeneous ways. For example, we have different areas in PicPay, growth, we have the commercial area, we have operations. So we need also to divide Brazil in a way that everybody can follow results, monitor results in the same way, and everybody can talk the same language. And our way to achieve this synergy between these different areas was how we approach the problem and how we are going to show you guys next year.
Okay, so hi, I'm Rafael Zendonadi. I work at data analytics team. So as Dani explained, this project was a MVP. So we decided to use only public data and create our own sales leads. I mean, commercial establishments that are able to be registered by a sales executive and consequently run PicPay products. Our main data source for this was the Brazilian Revenue Service. So from this list, we had to understand the geographic distribution of around 9 million leads and geocode them. So in that moment, considering it was the MVP, instead of using some kind of paid service, paid API, we decided to create our own geocoder using some database from Brazilian Institute of Geography. We also have done some tests with OSM, but the data was not very suitable for massive use in this project. So the next step was a territory clustering based on k-means classifier and business definitions. So two concepts were defined for Salesforce. Epicenter, which is the region where each sales executive operates. This is a planning level, a macro level, with each one containing at least 30,000 sales leads. The second, locations, localities, which are subdivisions of an epicenter. This is more tactical for field operations. For this one, each locality must contain at least the number of establishments that each sales can visit in a year. So with the clustering done, we had to decide where do we go first? And the answer was to localities with highest priority, where there are more PicPay users transacting. I mean, consumers using multiple products in different locations. Then, can you return, please?
Yep. This one?
Yeah.
Sorry.
So, no, for instance, we can observe in the figure that the lighter hexagonal represent more engaged regions, a situation that can be explained by several factors. The next, please. So this is our first version, a draft, basically a dashboard with two information layers. In the left side, we have the depth centers, the draw, and in the right, the localities. So we can understand the relation between them. In both cases, we can see some numbers on the labels, which are the priority rankings. I mean, they are placed to be attacked first. And this version is currently running, and sales executives already have mobile access to the map during their door-to-door daily tasks. And regarding understanding some patterns in different areas and comparing them, we are collecting some transactional data to evaluate performance indicators. Next, please. So the challenge of initial solution, here we have some points to be improved. The first point is improvement in the distribution of leads in each epicenter, considering the classifier. As this is a MVP, we intend to use in the future new data source and geocoding API to improve our data quality. As the consumers are moving around, we had to define some rules to prioritize the regions. And to conclude, the first version, I think, was important for data structuring and to understand the issues faced by sales executives. So Fernando will demonstrate now the next version that includes some improvements.
All right. Thank you. Thank you, Rafael. Hi, everyone. I'm Fernando, and I'm also part of the data team here at PicPay. And I'm going to be showing now in a bit more detail how we improved each of these localities that Rafael just explained and what we wanted to improve in each of them. So first, this first level, this less granular level, the localities, first thing we wanted to do is to make it respect these neighborhood constraints, or to respect the geography of the city. Then for epicenters, this a bit of higher granularity level or region, we wanted to make them to be balanced. So we wanted to, every epicenter that we generate had at least a similar amount of commercial establishments, of potential leads for PicPay. And third, we wanted to expand this model to the whole country. Brazil is very large, and we wanted to see to the same model would work in, for example, São Paulo, which is our biggest city, and also, for example, in the Amazon state, which we have a lot of very small cities, and we had to somehow combine them, and that's why we needed to create these another layer of aggregation, which is these macro regions. And finally, I'm going to talk about a little bit also of how we are now trying to enhance this prioritization method. So how do we say to PicPay executives and to our board that we should be focusing, for example, in epicenter A and not in epicenter B, for example. All right. So locality is this first level of aggregation. As Rafael said, it's much more tactical. So I add some examples here. This would serve as, for example, a sales executive to answer, okay, how do I divide my team this week? So should I send them to locality A or locality B? Or how many leads we converted these today in this locality? That's the kind of purpose of this geometry. And we still maintained using the k-means clustering, but we made two big changes here, two improvements. First of them is the geometry that we are using to aggregate to make this clustering process. And also we added some information that is the neighborhood information about that geometry. And I'm going to be explaining here. So the first change was this. We instead of using what we were using before, which is this H3 hexagonal index, we started using this another data set, which is a public data set provided by the IBGE, which is the Brazilian Institute of Geography and Statistics. And basically, they create this data set during the census period. So in 2010, they had one. Now they released another one for 2020. And they use it to apply the census research. And they divide all the country basically in these sectors, which is good for us because these sectors respect the geography of the city. So we understand that here we have, for example, a graveyard, or here we have a park, and it understands where we have a street or an avenue. And just by changing this geometry, it would make it made much easier for us to divide the territory, reminding that our intention in dividing the territory here is also to say, for example, okay, one sales executive is responsible for this region here up to this avenue, and another one is responsible for this other region up to another area. So that's why using this geometry here made the things much easier to correctly divide the city in detail. All right. And next, another thing we added here that was very helpful is while we're doing the clustering process, not only we are using as cluster variables the X and Y of the geometry of this census sector. So besides the X and Y of the sector, we are also using the X and Y of the neighborhood where this sector belongs to. And we constructed this information. And the big advantage is if you focus here on the center of the left image, you see, for example, in green, one of these locality that we generated with this spatial clustering. And in the left side, it does not respect the boundaries of this neighborhood. You see, there is this avenue in the middle called Avenida Paulista. This is São Paulo, by the way, the city of São Paulo. And it crosses this avenue, taking place also in another neighborhood. And the same happens also in a little bit further to the south here. But if you see in the right side of the image, now when we use this information as part of the clustering process, we have now a much better defined locality, respecting, for example, where one neighborhood finishes and another neighborhood ends. So this might make the easier of the operational level, the executives who are on the street trying to acquire new customers, make this division much simpler. Okay, so well, this was this first level locality. So now we clustered all the cities into localities, and now we want to group these localities into epicenters. So how we can group them in a way that every epicenter we generate would be balanced. And here, the major change we did was to change the algorithm. Instead of using the k-means algorithm, now we started using a different algorithm, the max-p regions, which is kind of a new algorithm. It was proposed in 2012 in this paper here. And the big change here is that not only it is applying a clustering technique, but we can have the capability of cluster and at the same time optimize the clustering, the clusters that are being generated according to one or many variables that we want. In this case, we wanted to optimize this clustering for the amount of commercial establishments we have in each epicenter, so the leads. And now I'm going to explain here. I think it will be easier to understand. So the difference of using this algorithm or another kind of spatial algorithm, not considering this optimization, is basically this. Here we have Rio de Janeiro, the city, and in the left you have a clustering generated epicenters with k-means, and in the right side with max-p regions. And we can see in the chart below the number of commercial establishments we have in each of these locations. And in the left side, we can see that it's very unbalanced. We have some of them, one here have, for example, 50,000 commercial establishments, and these other one have 5,000. And in the right side, we kind of solve this problem. We have a much better distribution, uniform distribution of leads in each region. Although it brings also some problems. For example, now we don't have a very uniform distribution of the area of each region. For example, if you see in the right image, if you compare the two regions that are in blue, this lighter blue and darker blue, the darker blue is a very large area, and the other one it's much smaller. So for example, if we assign one sales executive to the lighter blue region, it would be much easier for him to visit all the customers here and all the potential leads here, because they are much more concentrated. While in this other region, it would be much more difficult for him to visit, to cover all this area. And this, we had great discussions with our partners, the commercial planning team, the area we were helping with this project, but we still decided to go with this option on the right side. We maintain balanced regions, and we deal with these different distribution of area inside the operation. All right. So we generated epicenters like that I showed you in Rio de Janeiro for all the cities in Brazil. By the way, we have more than 5,000 cities. And then we needed, especially for the countryside of Brazil, we kind of had a problem. We have too many cities that are very small, and we need somehow another way to group them again. And for that, we decided to add a new layer. And the purpose of this layer, this macro region layer, would be as the same as epicenter, a more strategic point of view. It's not too much tactical. It's more like the kind of region the head of sales or the manager would use to ask questions like, so in which macro region should we focus that year? Or to which macro region should we be hiring more executives to enhance our sales there? And then we applied here the same strategy as we did before. We still use the max-p regions algorithm, making sure that we have a similar amount of leads in every macro region we generate. So we still optimize this variable. And just the main difference here is that we took advantage of another definition from the IBGE, the Brazilian Institute of Geography, which is an existing definition, aggregation of municipalities, of cities. So we took this existing definition from IBGE, which is the definition of micro regions of Brazil. So it divides the whole country in aggregation of cities, here as you see in the left side. And using the same technique as before, the MaxP regions, we generate the view you have in the right side. So these macro regions. And as the same way we did for respecting the neighborhoods in the localities, we did here we wanted this generation of macro regions to respect the states, or try to avoid putting two states together in the same macro region, and also this definition of mesoregions, which is another definition of the Brazilian Institute of Geography. So basically what we achieved here was this image that you see here. Here I'm showing, of course, just the urban areas of the country. So we used this view here to define the boundaries, but what we are interested in is just like the colored points here, which are the urban areas of the country. And then we have them clustered in this level, in this higher level of macro regions. We can zoom in and see them in this epicenter level. And then we can zoom in even further and see it in this locality level, right? So now we end up here. So, okay, we have a nice division that will work for the sales executive who is in the street, and also for our managers, for our head, for our C-level people who would need to take higher level decision and strategic decisions. But then this brought us other questions. So how now do we prioritize each of these regions? So how to say that we should be focusing in epicenter A and not epicenter B? And in order to do this, what we're doing is actually a work based on a classification model. So we're generating basically a probability of that customer, of that lead converting into a customer. And to generate this, I'm not entering into much of detail in this classification method, but it uses a lot of transactional data about our consumers. So inside this, how people are in the region of that. So we generate basically a probability of that lead becoming a customer if he receives a visit from our executive. And with this probability, we combine it with the lead revenue estimation. So we generate a estimation, a lifetime estimation of how much revenue this customer would bring us if he becomes a customer. And we generate this lead potential. So with this lead potential, we then can combine it, aggregate in any spatial level that we want. We can combine it in a locality level, for example, or epicenter, or in a macro region level. And we can even use other metrics we have, for example, the penetration of PicPay in that region, to somehow weight or penalize this potential. For example, if we have here, we define a locality potential is basically the sum of the leads in that area, and we can penalize localities that we already have a high penetration. We already have a lot of customers there, so we might want to prioritize regions where the penetrations of PicPay in the commercial establishments are lower. All right, and well, we think this is a good way to define our prioritization, because it works both in a macro level situation and in a intra-city level. For example, we can, with the same methodology, we can both say, for example, to the sales executive, where should be he focusing that month to achieve better potential, to achieve to acquire more customers. So into this intra-city level. And we can also be telling to the managers, to the head of sales department, where should we be focusing? For example, in which state of Brazil should we be focusing more? We have more potential, and should we be hiring, for example, more executives and enhancing our sales force? All right. So that's it. I hope we brought, I think, here a case, one of our cases here in more deep dive way, but I hope it it could share with you all a little bit of the insights we found during this process.
Thank you very much, Fernando, Daniela, and Rafael. It was really great to hear your examples. I can't see any questions in the chat right now, but I did want to quickly ask you, do you have any ideas for other use cases coming this year that you'd like to explore in particular? And perhaps you could give us an idea of what they might be.
Yeah, sure.
Yeah, sure.
Go on, Dani.
We've been talking about this, discussing. We also are going to apply this to some use cases regarding fraud. How we can understand fraud in a geographical spatial way. Also, if there is some pattern in some regions, and how we can use this as an input to our fraud models.
Mm-hmm. Fantastic. Fernando, anything to add? Or?
Oh yeah, with that also, as a follow-up of this project of defining geometries, you also want to add now another layer of how we help them to define goals. For example, we have defined all these regions, these epicenters, for example, and we still have to define key results or goals that every team in each of these epicenters have to meet. And this is also a process that we plan to use a lot of geospatial information, because it depends a lot on how our consumers are transacting in that region, the kind of establishments, the kind of points of interest that we have in that specific region. So we still plan to do some geospatial analysis in this sense too.
Fantastic. I've just realized that I did miss one question in the chat here, which was from Ozzy Castillo, who is asking, in terms of Salesforce allocation, how has COVID impacted this?
Yeah, we grew a lot. PicPay grew a lot during COVID. We were against the flow because we are a digital wallet, and also some government incentives people receive through PicPay. So we grew a lot our base, our client base. But regarding commercial establishment, we were affected because the sales force can't go to the streets because everything is closed. So we had to think of other methods with the growth team and campaigns and performance marketing. But we are also, it was good for us because we could take a step back and plan how we're going to come back after everything is good.
Fantastic. Yeah, interesting, and good that you've been able to thrive through a difficult year. We have another question here from Gerrit Genis, I'm not sure. He says, your presentation's been very interesting. And has transaction-based origin destination and drive time stroke distance been considered?
Sorry, I missed one part. Has consumer data, consumer transaction has been considered, and the second part?
Yeah, has transaction-based origin destinations and then also drive times and distance been considered?
Right.
For now, we've been using just the origin of the consumer. For example, if he is the active user, for example, sending some money P2P to another person, we are considering this first position. So basically, we are using special index, 883 model, and we consider just the first location. But it's a good idea in the future to consider both parts.
Absolutely. We have another question, very popular on the questions in this talk. So once you define those regions, how do you operationalize the solutions? Since I'm assuming these regions don't have governance representations like a province or a municipality has.
Yeah, these regions, sometimes they can mix to municipalities, or sometimes they are divided intra a municipality. But this is just a division that we also together with Carto, we make this all these maps available for the executives. So when they go to the streets, they have access to which extent of the region it's his responsibility, of which extent it's another's executive responsibility, and they can move and try to convert customers all around this area, even if it's another city or another state, for example.
Yeah, because we also plot the leads, so they know where the leads are in these locations.
Mm-hmm. And is that connecting directly to your CRM for leads, or are you moving them in CSV files, or?
We're kind of integrating this right now. We with the help, we are actually started using a CRM, Salesforce, and we are trying to see how we're going to integrate that with Carto and this map together.
Fantastic. Okay, well, thank you so much for joining us. Muito obrigada, and we will be in touch. Have a great rest of the day. If everybody else